So today we will cover classification. Last week we have covered regression analysis. Okay, so perbezaan di antara dua ini, Cynthia 3 markah sudah. Okay, so perbezaan di antara regression and classification. Regression, you want to forecast. The keyword is forecast, kan? Meaning that you want to estimate the value of numerical value depending on the series of value that you have. Contohnya, you want to forecast temperature, you want to forecast profit, or you want to forecast exchange rate based on previous values. So forecasting only applicable to numerical values. Okay? So today we will look into classification in which it will address the problem of being able to predict. You want to do prediction. Contohnya, you want to predict sama ada you ada disease X or Y. But before you can do prediction, you need to be able to draw a line to say that they belong to class X or Y. So this is classification, dividing your data into two classes, maximize the true positive and true negative. Masih ingat lagi? What is true positive? The actual value is X and the predicted value is also X, true positive lah. True negative is the other one, Y. The actual label is Y and that item is predicted as label Y. So true negative, true positive, true negative. We want to maximize this. Okay. Kalau dia punya label is X, which is positive, tapi dia kena predicted as Y. So this is what? Dia punya actual class label is X, which is positive, tapi dia kena predicted as Y, which is negative. No, dia false negative lah. Dia kena classify as negative, false negative. Okay, so contohnya macam ni, you have, okay, this is your positive, this is the negative. So kalau that item belong to here, so dia punya actual label is positive kan? Tapi dia kena predict di sini. They belong to negative class. So that means false negative. Yang dia kena predict as negative is false. Okay. Tapi kalau the actual label is here, tapi dia predicted as di dalam sini. So this is false positive. Okay. So what we want to do is we want to maximize the true positive, which is dia belong to the positive class and dia predicted as positive. So this is true positive and this is true negative. Okay, so that is the task of classification. You want to be able to draw a line to say that it will maximize the number of true positive and true negative. Okay, so ini dia punya intro lah, just to give you the basic description of classification. So kalau you able to draw a line, then you say, now given a new item, I want to predict sama ada ini belong to plus or negative. So that's how we differentiate prediction and forecasting. Forecasting is for regression. Prediction is for classification. Okay. So we have studied regression last week. Now we go into the here. Okay. So like I mentioned in the first class, for classification, we need to be able to have this, the class label. So bila kamu dibagi itu dataset, you have to look at which one is your dependent variable, or which one the features that exist in the dataset is called class label. Okay. Okay, contohnya macam ni. We want to be able to classify a car. So they said, okay, how do you classify a family car? So the question is, the prediction is car X is a family car. Tapi to consider a family car, you must have some features ataupun kriteria dia. So contohnya besar, how many seats, and berapa power dia, and berapa size, and so on. Tapi in this example, we will use the size. No. Later on, I will show you the graph. So di sini the question is, if you want to predict the car is a family car or not, so we will say, okay, kalau positif, they are belong to family car. Kalau negatif, they are not belong to family car. So itu sajalah. So ini dipanggil binary classification, cuma ada dua classes saja. Dua classes saja. Okay, so your input will be all the features that you need to consider. So contohnya size ataupun number of seater. Kalau color, can you consider that? Not relevant kan? Kalau year manufacture, no kan? So these are the things that we need to consider. What features ataupun karakteristik yang kita boleh ambil sebagai independent variable to classify a car as family car. Okay. So in this case, we may look into the price or the engine power. So when we plot them here, so yang dalam ni is all the family car. Okay. And yang luar tu, yang negatif tu is non-family car. Okay, so di sini kita plot using the price and also the engine power. So given X, so X is the set of data that you use to train. So you want to do classification, one if X is positive, so this is all the positive. So meaning that they belong to family car, and 0 if they are negative. So meaning that we have two binary, 0 or 1. 1 if they are family car. Okay. Okay, when we have this set of data, kita tidak nampak nih. So when we plot, we see this one. So our objective is, okay, if we draw a box to cover all the 5 positive sample that we have this value. So the price is within this value P1 and P2. And also the engine power is between E1 and E2. Okay. So how do you get this number? By just estimating only lah. So you want to draw a line that will separate positive and negative. Okay. So when we say we train the model, basically we are estimating the border, because the border can be like this, very, very small. Yeah? So many options you have. So when we say modeling, is basically you try so many boundary line that will maximize the true positive and true negative. We don't want to draw a line something like this, okay? Because we miss this one. So if we miss this one, this is called what? false one. So if we draw a line something like this, so this is positive lah. So what happened to this? This is considered as negative lah. So that is called false negative. Tapi if we draw a line something like this, so what happened to this? False positive. What happened to this? False negative. So we want to reduce the number of false negative and false positive. So that's why they call it training the model. We want to estimate the boxes that will maximize true positive and true negative. Okay. So to proceed, so the program that we have ini dia tidak pandai. So sometimes they miss something like this. So they say, okay, the hypothesis that will be produced by the model, this is the estimation of area boundary. So yang kuning tu is the hypothesis provided by the model. They say, okay, kalau I draw this line, it will still cover the positive nicely, and it will still cover the negative nicely, right? Okay. Tapi there is a probability that this area yang di luar biru ni, if you have new sample, you want to classify or you want to predict, if they are fall here, dalam sinilah, so this is false positive kan? Because yang kuning tu is defined by the model. They say, okay, dalam kawasan kuning tu semua must be positive. So if a new sample fall di kawasan tu, that is false positive. So similar to here, if this is positive here, so by right they're supposed to be okay. Tapi according to the model, yang kawasan kuning itu saja yang positif. So kalau positif yang di sini, ini dipanggil false negative because the hypothesis say that only within this yellow line. Tapi yang sebenarnya is this one, blue. So we want to, when they say, I want to have the yellow boxes to match the blue boxes, supaya they reduce positive, false positive and false negative. Okay, and we can define this. So let's suppose yang blue tu, yang ada garis biru tu yang ini yang sebenarnya. Tapi the model can say I can go as specific as this. So this is very specific. Or I can go as general as possible. So the estimation is this big. Okay. So when we say we train the model, basically we want to maximize the matching between the actual and also the hypothesis. Boleh? So this is the mathematical background here. So when we say with training, basically we want to draw a line that separate the positive and negative. Okay, so this is the margin that we are looking into. So how general we want to go or how specific we want to go. Okay, so when we talk about the method that we can use, we have so many algorithms here. So you will learn all this in your machine learning for data science. But today, this is called fundamental of data science. I will introduce you what is classification, and I will cover one of them only. So if you want to learn more, then you can study the rest or you wait for the machine learning course. Okay. After this, you'll be learning data mining again, data mining and warehousing. So basically, we are looking into how do you store your data in a warehouse, and then how do you apply tools to do data mining. Data mining is basically extracting frequent pattern from your data set. So that is called data mining. Okay. So when we say binary, so now we are looking into binary, but we also cover multi-class classification, which involve more than two classes. Okay, so for binary, we only have two classes, and for multi-class classification, we have more than two. So that is the definition: two class instance and multiple class label. So that's the difference between these two. So we start with the binary classification. But to perform this, we ada ni ada empat poin lah. Okay, multi-class ni, we can apply the same concept as this. So if you look at the binary classification, we have so many options to do the line here. Okay. Okay, the main objective dalam case ni is we want to separate the positive and the negative here so that the distance is maximized. So the distance is, we want to draw a line that separate these two classes that will separate the distance between the item that belong to one class to the line. So we want to maximize. We don't want to have something like this. Dia maximize the other part, tapi di sini there is a possibility for you to have the bulat tu di sini. So this is error. So we want to draw line di tengah-tengah supaya dia fair. Okay. So to perform the multi-class classification, because for this one we just simply draw a line, right? Okay. For multi-class, we can apply the same concept as the binary, tapi dia ada dua jenis. Okay. So for instance, dalam multi-class ni, we have, based on your observation, how many classes we have? 3, kan? Okay, what happen if you have this one? They cannot tell whether they belong to the sport car or luxury sedan, right? So you don't want to have the boxes to be overlapping on top of each other. So tidak mau ada tulang, because that one will give you error. And also, when you want to draw the boxes, it must cover everything, because if you have this, then you don't know where to put them. You cannot predict they belong to sport car atau luxury sedan or family car. Kan? So the tips here is that when you do the modeling, you need to cover everything, and you do not want to have one label, one item to have two labels, multiple label. So you don't want to have overlapping. Okay. So given this is your data set. Okay. So for each class that you have, you want to have the member itself. This one telling you that you will have multiple classes because we are using I and J here. And we want to have this hypothesis for all the classes, that this hypothesis, for example, green, yellow, and purple, they should not have overlapping, and it should cover all the item that we have. So itu dia punya first assumption to make sure we have a good model. Okay. Okay. Now The question is, can we use binary classifier to construct a multi-class classifier? So tadi kita go back tadi itu. So for binary classification, we just draw a line. So they said, can I apply the same concept here for multi-class? Yes. If you look at the multi-class classification, basically you can draw a line to separate them, right? Tapi there must be a process lah. Okay. So how do you do that one? Okay. So first thing what we can do is that, okay, we have multi-class di sini, 3 classes. So one versus all means you pick one of the label versus the remaining item that we have. So for instance, we take the green first, then we draw a line here. Then we take the square one, and then we draw a line here. Then the X, then we can draw a line. So once we have finished with that one, then we should be able to come up with this, right? So much easier. So this is what we call one label versus the other's label. Okay. So this one can be converted. So if you have this label here, so for instance, we have 3 classes, green, blue, red here. So to convert them, for instance, we take this one, we take the green one. So we take the green. So this is your main class. So other than that, for example, the blue and the red, you must convert them to a common one. Contohnya you put all. This is all. So from 3 label to 2 labels. Okay. So dalam contoh ini, okay, for green and green, so they are positive, and the rest is negative. So once you model this, then you, when I say model, meaning that once you able to draw a line to separate this, then you repeat again for the blue and the red. Okay, so you have this blue, and then the rest is negative, and then the red, this is the positive, and the rest is negative. So that's how you convert your data set, and then you would be able to draw a line. Tapi dalam the actual penggunaan dia tu, you cannot see this, because when you apply the method, dia akan buat sendiri dalam tu, the background process. What you see in front is just the result. Okay, so this is how they do the process of performing the training for multi-class. They convert, they use the one versus all. Okay. So basically you have the data set here. Okay, and since we have all the, okay, this is for the green, this is for the blue, this is for the red. So they will have their punya online. So di sini you will be able to see the 3 line. Okay, once you have the new item, so you can consider they belong to this green, blue, or red. So they will have the final answer here. Okay. Okay, tapi sometimes we have problem here. For instance, for this one, there'll be no problem lah, because for the blue, for the red, and for the green, we will have no problem here, because we can simply draw the line. Tapi if we have something like this, we have problem with this. Sebab yang black one tu, we are not able to do. Sebab dia di tengah-tengah. So macam mana kita mau buat? So if we're able to predict the blue, the red, and the green one, Oke, di sini kita ada berapa? Sini ada 5, sini ada 6, sini ada 6. So sini ada 3. So the total item would be 20, right? So if we are able to predict the green, which is 6, able to predict the blue and the red, but we fail to predict the black one, our accuracy is still how many percent? No, this one is 6. Yeah. So 70%. So 70% meaning that this is 85%. Okay? Accuracy. And so in the eyes of us, we say 85% is very, very high. Tapi sekiranya yang the black one is very critical, meaning that none of your algorithm able to detect or predict the black one. So still your mission is failed. Okay, you're not able to predict if a new item coming in and they belong to the black circle, your model cannot predict this. Okay, so we need some kind of alternative method on how to solve this problem. Okay, so we have problem with this one. Okay, so because of that, they introduced this 1 versus 1. So 1 versus 1 will be able to solve this problem. And they said that if you have, I go back to here, di sini berapa number of classes you have? 4, right? Okay, so meaning that your n is 4. Okay, so based on this approach, 1 versus 1, they say that if your n is 4, the only way for you to double check whether your approach is good for 1 versus 1 is that you must have 4 times 3 divided by 2. So what is the number? 6. So 6. So they said that if you have classes of 4, then you should have 6 binary classifier. Okay, I go back to here. Okay, this is how many classes we have here? 3. Okay, how many binary classifier here? This is considered as one binary classifier because they are separate positive and negative. Kan? So binary classifier, this is one. So this is the second one, this is the third one. So for 3 classes, you need to have 3 binary classifier, right? So this is 1 versus all. Okay? But the other one, 1 versus 1, they say that, okay, for instance, if you have n classes, you should have this number of binary classifier. So in our example, we have 4. So meaning that we need to build 6 binary classifier. So this is the approach that we have. Okay. Okay. So this is the example that we have just now. If we have 3 classes, so that means we should have 3 binary classifier. So based on this formula. So this is okay, right? Okay, now we have this. So we should have 6 binary classifier. Okay, so why we consider this one 6? Because you see, this is 1, 2, 3, 4, 5, 6. Kan? So we want to draw that line. How we draw that line? Since we say this is 1 versus 1, so meaning that one class versus one class. So di sini we pick the blue and the black. So this line will represent this line here. Okay. Then we pick another one, the blue versus the red. So we draw the line there. Blue versus green, black versus green, red versus green, black versus the red, and we have 6 model. So if we combine all this line, then we should be able to construct this. Okay, so di sini for the first 3 we maintain the blue versus the others, and then the second one we look into the green first, since we have this one already, so this is 2. So the last one is the black, but the black we already have for the blue and the green. Okay, so this is the process that involved when we want to do multi-class classification. You will not see this one. This will be processed behind the scene, but the question that you should be looking at is this one. I erase first everything. The issue that we want to look into here is this one. How do we draw the line to maximize the separation between 2 classes? Okay, so this line can move up and down. This one can move up and down. Okay. Okay, using the knowledge that you have studied before, how do you measure this? Using the knowledge that you learned before in the past 5 weeks, what formula can be used? So you need to think, apa yang sudah belajar in the past 5 weeks yang involve calculation? Hah? Yang ada log tuh kan? Apa tuh? Dipanggil apa tuh? Dipanggil information gain kan? So information gain dia based on entropy kan? Okay. So di sinilah guna dia nih. So if I go back to the previous lecture, I said, okay, if I separate this into 2 partition, then berapa entropy before and after. So kita apply di sini lah. Okay. So that's why very important for us to know what method or what benchmarking we use to separate them. So you study entropy, you study IG, of course that one will be asked in your final, in your midterm lah. Okay. And also you learn how to simplify your data using discretization kan. Also use entropy juga. So very important, entropy and IG. So that's how we determine the best line that will separate these 2 classes by using information gain. Okay, for instance, okay, before the splitting, okay, before you split these 2 into 2, you count the number of No, you count the entropy. What is the entropy for this? You must ingat. So what is the entropy for this one? This is 3/9 log 2, 3/9 plus 6/9 log 2, 6/9, and everything should be negative. Okay, so that is before you split. This is the entropy. Okay, so when you split them into two, assuming that we correctly classify them, so this one should be 3/3 log 2, 3/3, and for this one, this is 6/6 log 2, 6/6. So dia punya pemberat is 3/9 plus the pemberat for this one is 6/9. This one is negatif lagi lah. Okay, so di sana lah kita pakai entropy to split them. Okay, so I will show you that one in the next lecture. Okay, so these are the algorithm that we can use for multi-class classifier. We have k-nearest neighbor, decision tree, naive Bayes, random forest, gradient boosting. So this one is considered as ensemble. Okay, if I go back to the first slide here. So this is ensemble. So what happened is that we have classification here, and we have neural network here. So we take one from this class, and then we take, this is controller, and we combine them to become two. So in ensemble, meaning that we have more than one model that we put in as your meta classifier. Okay, so you will learn all those things in the machine learning again. Okay, any question? So far, okay. 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 So we managed to complete the lecture in 1 hour. You know why? Because you guys never ask questions. But all of you have taken psychology, kan? Kan? Ada ambil nggak? Rugi lah. Masa dulu kami before pergi States, we were asked to take psychology 101. They say, why do we need to take this psychology? They said, because you need to understand how people study and learn. So our brain boleh fokus berapa minit saja? 20-25 minutes lah. So after that, what happened to your brain? Either you want to sleep or you plan to go after this, mau pergi mana? And malam ni I buat apa? Mau pergi tengok wayang kah atau tidak? Or you terpikir you ada assignment? Or you terpikir you want to balik kampung and so on? So the ideal time for study is only 45 minutes. Okay. Okay, so for the conclusion for this, by now you should be able to say, okay, I have studied classification, and what does it means by having binary and multi-class classification. And for multi-class, we have one versus all and one versus one. Okay. Okay. Any question? or 40 minutes.